So today we're going to do best method. So first let's start by adding. So I'm going to write that first equation. Next we want this equation right here. I'm sorry? Oh, thank you. Thank you for catching that. Okay, so when we look at the second equation down here, we want x to be on this side of the equation so that we can compare the two equations. So when x comes over here on this side of the equation, we're subtracting it from this side, correct? So it's going to be a negative x when we bring it over. Equals 4. Alright, so now by elimination, I can just combine the two equations. X and negative x are zero pairs, so they cancel out. And I have a negative 2y and a positive 3y. They have different signs, so we find the difference. The difference between 3 and 2 is 1. And is it a positive or a negative y? Positive, good. Equals, different signs, we find the difference. 4 and 1 is 3. Positive or negative? Positive. Now we want to substitute back into the original equation. So I'm going to write out my equation. And substitute 3 for y. X minus 6 equals negative 1. Add a 6 to both sides. And I get x equals 5. So my solution is, we can erase this now, 5, 3. All right. Let's substitute next. What would be a nice, easy way to substitute? Would you manipulate the top equation, or would you manipulate the bottom equation? The bottom, why? Oh, because it's positive. Well, you could do the same thing at the top. You could add 2y, perfect, Andrew said it perfectly. You could add 2y, and so it would come over here, and it would be x equals. Or you could subtract 4, and then you could have it, the 4 over here, and it would be x equals. Which one do you want to do? Top one? Okay. So, when I add 2y and bring it over on this side, I get x equals 2y minus 1, and 3y equals, you want me to just substitute it right in? Instead of writing x? Is everybody okay with that? I wrote the second equation, but instead of writing x plus 4, I put parentheses because we're going to substitute for x, right? So let's substitute for x. What's x again? Good, Sarah. It's right above me, right here. X equals 2y minus 1. 2y minus 1. So I get 3y equals 2y minus 1 plus 4. Simplify it further, and I get 2y plus 3. Subtract 2y from both sides. And I get y equals 3. So far it matches, correct? All right, what's my final step? Substitute it back in. Into here. So I have x equals 2y minus 1. substitute y for 3, and I get x equals 6 minus 1, x equals 5. Since we're right here, you want to graph? Does that sound good? All right, how could we graph this? What do I need to do? What form does it need to be in? We need to put it in y equals mx plus b, slope-intercept form. Okay, so what would be my first step in that first equation to put it into slope-intercept form? Vanessa, what would you do? Switch it? Okay, switch what? Good. So what do I need to do right here to get 2y by itself? Oh, you want to put the y on this side. Okay, let's leave it right there. We could. You're not wrong. But normally when we have this form right here, see that? I want to keep y on this side. So if I want to keep y on this side, what would I do with this x? Good job. So x minus 2y equals negative 1. We're going to subtract x from both sides, and I get negative 2y equals negative x minus 1. Now what do I do? How about Alex? What do I do now? Yes.
Well, divide 2 by everything.
Good. Negative 2 though. So I can see this better. Divide everything by negative 2. Uh-oh. This doesn't look like it's going to come out very well. Y equals, this is in simplest form, so I have to pull that fraction out in front of the x, so 1/2 x, and this becomes positive 1/2. Now this is a really good example, because would you want to graph this? As soon as I realize that there's a fraction, I'd probably stop and say, this is not a good one to graph, because it's not going to be very accurate, right? But should we just continue? You know what, I think we're going to stop right there, because I wouldn't continue at this point. I would say, okay, let's graph this line. 1/2 would be, what, right there? You'd go up a half of the point. You know, let's make this bigger. I'm sorry, Elgin, what? What's there? Of graphing? Really? Okay, it won't, I'm not going to manipulate it. I would have to take a picture of it and then make it bigger. So let's just graph it like this. So I go up a half of a tick mark on a grid, right? And then I would have to go up 1/2 for my slope, which you can't even see. Up 1/2, and that would be my line. And as you can see, it's just not a very good method for this particular system of equations. Huh, it won't let me go back up. That's weird. All right, so our final method is multiplying. Do I even need to do this method? This is important too. Let's go back and look at this right here. When we manipulated the equations so we could line them up, I got x minus 2y equals negative 1. And negative x plus 3y equals 4. Do I need to multiply anything? You really can't, right? I mean, I suppose you could. It would just complicate things. They're already ready to be eliminated, right? And so if we did this problem, we would be doing it exactly like this problem. No different. Okay? So at this point, I would say this is just adding by elimination. Okay? Any questions?